So in section 3.7, we will solve quadratic, polynomial, or rational inequalities. Okay. So inequalities means we have been solving the equation. We did solve our polynomial equation. We did solve the quadratic equation. Okay, and we did solve rational equation. Now we are solving the inequalities. Okay, so if we have, so inequalities means we see a greater than, right, or less than sign, greater than equals to sign, less than equals to sign, or not equals to sign. So if we have this sign in the mathematical statement, then these are the inequalities. Okay, so we will be given an inequalities and solving the inequalities. Now if we have an inequality, how many solutions do we get? Does that depend on what type of inequality we have, or how do we know how many solutions do we find for the inequality? So does it depend on the degree of polynomial or a rational? Now let me take a very simple example. So let me take a inequality x greater than 2. So this is the simplest form of the inequality. Now what does this tell us? So our x is greater than 2, right? So every number which is greater than 2 is x. Now how many solutions do we have here? So how many number do we have which is greater than 2? Infinitely many, right? So we have the infinitely many solution. Okay, so inequalities, if you see an inequality, you always get infinitely many solution, and we write down those solution in an interval notation. Okay, if we have an equation, like if we have a linear equation is an equation with a degree 1, we have one solution. If we have a quadratic equation have a degree 2, so we get two solution. If you have a cubic equation, it means you have an equation with a degree 3, you get a 3 solution, at least 3 or less solution, right? Similarly, if we have a equation with a degree 4, then our solution is 4 or less than 4. But when we are talking about the inequality, we always get the infinitely many solutions, and we use interval notation to write down the solution. Okay, so here, so we have these steps for solving quadratic, polynomial, and rational inequalities. Now at first, let's solve this example. Okay, let's go to step 1. Now what step 1 tells us is that first rewrite the inequality with a 0 on the right side. So you have an inequality, does not matter it is a linear or a quadratic, polynomial, or a rational. If you have an inequality, make your one side of the inequality 0. Okay, now let's do that for our example 1. Now in our example 1, we have this quadratic, this is the quadratic, right? So this is quadratic inequality, and we already have 0 on the right side, so we can skip step 1. Okay, now let's go to step 2. In step 2, we factor the non-zero side. It means non-zero side means for this inequality, our left side is non-zero, right? So this is our non-zero side. So we factor this non-zero side and find the 0 of each factor in the inequality. So let's factor the non-zero side. Now what method do we use to factor? This is a quadratic form with the coefficient other than 1. So we use FOIL or AC method. AC method, the coefficient of square term is not 1. So we use AC method. So this is our A, right? So this is our C. So A times C, which is 2 times 2 is 4. Okay. We write down every pair of factor of 4. So 1, 4, 2, 2. So these are the pair of factor of 4. Okay, now we choose one factor. Okay, and we use that factor to rewrite our middle term, which is negative 3x. Now which pair of factor do we choose to rewrite negative 3x? 1 and 4, right? Now how do we rewrite negative 3x using 1 and 4? So which one is negative and which one should be positive here? 4 has to be negative, right? Because 3 is negative. So we have 2x squared as it is. So we have 2x square. We are rewriting negative 3x using this pair of factor. So negative 3x is same as negative 4. 4 has to be negative 4x and 1 has to be positive. So 1 times x, or simply you can write x, and we have negative 2 as it is, greater than 0. Okay. Now we have a 4 terms. Let's make a pair of first 2 term and last 2 terms. We are trying to factorize. Okay. So in the first 2 terms, our common factor is 2x. So if you factor out 2x from 2x square, you divide 2x square by 2x, we get x. Okay. Similarly, if you factor out 2x from negative 4x divided by 2x is negative 2. Okay, so we have negative 2 plus, in the last 2 terms, what is the common factor? We can always find positive 1 as a common factor, right? So let's factor out positive 1. So we have 1 as a common factor, so x minus 2 greater than 0. So we have x minus 2. So this factor is common. So let's factor out x minus 2 is common. And the remaining we have 2x plus 1 greater than 0. Now the next here we have the factor. So we already have the 2 factor. Now we find 0 of each factor. It means we find a number that make each factor equals to 0. Now for what x value this factor is 0? Can you tell me a x for which make this factor equals to 0? 2, right? So 2 is 1 0. Okay, so let's write the zeros. So 2 is 1 0. Now let's check the next factor. So this is our second factor. Now for what x value this expression is 0? Okay, now how do you find that negative 1/2? So what you can do is that you can write this factor. So like in the side, you can write this factor 2x plus 1 and make it equals to 0. Solve this equation. You subtract 1, this cancel. You have 2x equals to negative 1 divided by 2, x equals to negative 1/2. And when you choose your x to be 1/2, you get second factor equals to 0. Okay, so our next factor is negative 1/2. First step, you make right side 0. Second step, you factorize the left side. Okay, once you factorize, you find a x. Okay, you find a 0 for each factor. It means you find a x which make each factor 0. Okay, so here if you substitute 2, this factor is 0. If you substitute negative 1/2 for x, this factor is 0. So we find the 0 of the left side. That is the second step. Okay, now let's see what we have in the step 3. The resulting zeros. Now we have these 2 zeros. These zeros divide the x-axis into multiple intervals. Okay, now let's draw a number line. Okay, so we have a number line, negative infinity to positive infinity. Okay, now we use these zeros to divide our number line. So we have negative 1/2. So let's say this is negative 1/2. Okay, and this is positive 2/2. So we use the zeros to divide our number line into different interval. Now we have, how many interval do we have? So we have this interval, right? So we have this interval and we have this. So we have 3 intervals. So we use the zeros to divide our number lines into 3 different intervals. Okay, now the next thing, we choose a number, testing number from each interval. You can choose any number from each interval. Okay, from the first interval, what number do you want to choose? You can choose any number. Negative 1. Okay, from the middle interval, what number do you want to choose? So in between negative 1/2 and 2, we can always choose 0, right? Or 1, you can do 1 or 0. Okay, and for the last interval, let's go with 3. Okay, now so you choose any number from each interval. Now we check whether this testing number is a solution for our inequality or not. let me write our inequality is 2x square. So let me write down here 2x square minus 3x minus 2 greater than 0. So this is the inequality. Now how do we check -1 is the solution for this interval, sorry, for this inequality or not? We substitute -1 for every x. Let's do that. So if you substitute -1 for every x, so we have 2 times -1 square, that is +1, minus 3 times -1, that is +3, minus 2 greater than 0. Now is it true? 2 times 1 is 2, 2 plus 3 is 5, 5 minus 2 is 3, 3 is greater than 0. That's true, right? True means this interval is a solution. So we have this interval as a solution. Now let's check for the next testing point. Now let's go and check whether 0 is a solution or not. So you do the same thing. You substitute 0 for every x in your inequality. So we have 2 times 0 square is 0, minus 3 times 0 0, minus 2 greater than 0. So we have 2 times 0, 0, that's 0, 0 minus 2, minus 2 greater than 0. That's not true, that's false. So it means this interval is not a solution. Okay, now let's try for the third testing point 3. So we have this first solution, okay, second is not a solution. Now if we substitute 3 for every x, okay, if we substitute 3 for every x, so we have 2 times 3 square 9, minus 3 times 3 9, minus 2, and this is greater than 0, right? 2 times 9 is 18, 18 minus 9 is 9, 9 minus 2 is 7, 7 is greater than 0. That's true. True means this third interval is also solution for this inequality. Okay, now the next thing we also need to check, what about these points? So what about these -1/2 and +2? Are these the solution for this inequality or not? What do you think about -1/2? So let's substitute. The method is same. You substitute -1/2 for each x. So we have 2 times -1/2 squared, that is +1/4, minus 3 times -1/2, that is +3/2, minus 2 greater than 0. Okay, now 2/4, that is 0.5, right? That's 0.5. 3/2 is 1.5. So 0.5 plus 1.5, that is 2. 2 minus 2 is 0. 0 is greater than 0. True or false? False, right? So -1/2 is not a solution. It means we have to include -1/2 or exclude -1/2? It's not a solution, so we have to exclude. It means we're going to have an open circle at -1/2. So we're going to have an open circle. It means we're going to use parentheses. Similarly, if we check for 2, now is 2 a solution for this inequality? So let's substitute 2 times 2 square 4, minus 3 times 2 6, minus 2 greater than 0. 2 times 4 8, 8 minus 6, that is +2. 2 minus 2 0, 0 is greater than 0. That is not true. It means 2 is not a solution. So this is not solution, 2 is not a solution. It's not a solution. It means we're gonna use a open circle. Okay, an open circle is same as parentheses. So if you are including, you're gonna use a bracket. If you are excluding, you're gonna use parentheses. Now what is our solution here? First interval and second interval. Our first interval is from -infinity to -1/2. -1/2 is not a solution, so we have parentheses. Okay, or it means union, the last interval from 2 to +infinity. 2 is not a solution, so parentheses and parentheses on both sides. And this is our solution for this inequality. So you have to check for the zeros. Okay, you have to make sure whether the zeros are the solution or not. That gives you that gives you an option to choose parenthesis or a bracket. Okay, now so here basically what we did, our first step was making 0 on the right side. Okay, second step is factorizing the left side. You factorize left side. Okay, third step, you find the zeros of the factor. Okay, you find the x that make factor 0. Okay, and we use the zeros to divide our number line. Okay, that is the next step. Now you have the interval. Now from each interval you choose a testing point, testing number. It does not matter what number you choose. Okay, you can choose any number in that interval. Now the last step is you check each testing number and these zeros are the solution or not by substituting in the inequality. If you get true, the interval is solution. If you get false, interval is not a solution. Okay, and at the end, if you have more than one interval as a solution, you're going to use a union. Okay, solution can be from first set or second set. So, and for or we use union. So this is how we solve our quadratic inequality. Now let me know if you have any question here. Now let's go to the example 2 and solve this inequality. What kind of inequality is this? Is it a polynomial, quadratic, linear, or rational? What kind of inequality is this one? So what kind of expression is this? Is this the polynomial or a quadratic or a rational? Rational, right? So if you have your variable in the denominator, that is a rational inequality. Okay, so we have this rational inequality, x square minus 9 divided x plus 5 greater than 0. First step, you make right side equals to 0. So we already have right side equals to 0, so we can ignore the first step. Second step, we factorize our numerator and denominator. If you can factorize, you factorize your numerator and denominator. Now in the numerator we have x square minus 9. Okay, now how do we factorize this? What method do we use to factorize x square minus 9? So this is a binomial, difference of binomial, and you can use FOIL. Okay, or you can rewrite this as a x square. 9 is same as 3 square, right, divided by x plus 5 greater than 0. Now we have difference of square term. If you have a difference of square term, the factor is, if you have difference of square, so you have a square minus b square, then the factor is sum of these two number and times the difference of these two number. Yes.
If it's rational, we need to include the domain.
We need to. So I'll be there. Okay. So here, so second step we factorize. So using this difference of square, our factor in the numerator is x plus 3 times x minus 3 divided by x plus 5 greater than 0. So you factorize your numerator and denominator. Okay. Now the next is finding a 0. Okay, finding a 0 here. And this is a rational function. We need to find one more thing. We need to find x. We need to find the x that makes our denominator equals to 0. Okay, this is a rational. So we don't want our x that makes denominator equals to 0. Okay, so you find the 0 and the next we find x. Okay, that makes denominator equals to 0. Okay, now what are the zeros for each factor? Now for what x value, this first factor is 0, so we have x plus 3 here. So for what x value this factor is 0? For what x value x plus 3 is 0? For negative 3, right? So if you choose x equals to negative 3, so negative 3. Now let's go to the second factor. For what x value this factor is 0? Positive 3. So these two are the 0. Now this is the rational. We check, do we have a x that makes our denominator 0? So for what x value our denominator is equals to 0? Negative 5. So we have a negative 5. And we use these numbers to divide our number line. Okay, So and this is what we do only for the rational. If you have a rational inequality, make sure you include the number that make denominator equals to 0 to divide your number line. Okay, now we draw a number line. So let's draw a number line. So we have positive infinity, we have negative infinity. So we have -5. So let's say we have -5 here. We have -3 here. We have +3. So make sure to use the zeros of the numerator and the x that makes denominator equals to 0 to divide the number line. This is the one more step. Okay, that's the extra step for rational inequality. You have to include the number that makes denominator 0. Now we have how many interval we have? So we have 1 interval, 2, 4 intervals. Okay, and we need to choose the correct interval as our solution. So next step is we choose a testing number from each interval. So what number do you want to choose from the first interval? So -6, right? Let's do -6. So in between -5 and -3, we can choose -4. In between -3 and 3, we can choose 0. And from 3 to positive infinity, we can go with 4. Or you can choose any number. Okay. Now we have to check each of these number. Okay, we have to check all these number, and even this number are the solution for this inequality or not. So let me write the inequality. So we have our inequality x square minus 9. So x square minus 9 divided by x plus 5 greater than 0. So this is the inequality. Now let's check whether -6 is a solution or not. And how do we do that? You substitute in the inequality. So -6 square is 36 minus 9 divided by -6 plus 1, -1 greater than 0. Is it true or false? So 36 minus 9, that is 25. 25 divided by -1, -25 is greater than 0. True or false? That's false, right? So this is not a solution. Now let's check for -5. Now what about -5? So if you substitute -5 in this inequality, so we have -5 square, 25 minus 9, -5 plus 5, 0 greater than 0. So we have 25 minus 9, that is 16 over 0. What is 16 over 0? No, that's undefined. It's undefined. Okay, and so undefined means, so this is not true. Okay, so we don't know what number is this. Okay, so this is the infinity, and infinity is, okay, so this is undefined. It means this -5 is not a solution. Okay, so the x value that make denominator equals to 0 is always not a solution. Okay, you can always use a parenthesis. Not a solution means we're gonna use a parenthesis here or the open circle. Okay, now let's check with -4. Now is our -4 a solution for this inequality or not? So you substitute here. So -4 square is 16 minus 9. -4 plus 1, sorry, plus 5 is +1 greater than 0. 16 minus 9, that is 7. 7 divided by 1. 7 greater than 0. That's true, right? It means -4 is a solution. Okay, so our interval 2 is a solution. Now let's check for -3. Is our -3 a solution for this inequality or not? So -3 square is +9 minus 9 divided by, okay, so we choose -3 plus 5, that is 2 greater than 0. So 9 minus 9, 0. 0 divided by 2 is, it is 0, and 0 is greater than 0, which is false. It means -3 is not a solution. It means we have an open circle here. Okay, so we have an open circle here, but our interval 2 is the solution. Okay, so this is the solution. Now let's check for 0. Now is 0 a solution for this inequality? So you substitute 0 for every x. 0 is square. 0 minus 9 divided by 0 plus 5, 5 greater than 0. -9 divided by 5 is greater than 0. That's false, right? We have a negative number. So this interval is not a solution. Now let's check for +3. So positive 3. So 3 square is 9 minus 9 divided by 3 plus 5, 8 greater than 0. 9 minus 9, 0. 0 divided by 8 is 0. 0 is greater than 0. That's false, right? It means 3 is not a solution. It means we have a parenthesis here. Now, let's check for 4. Now, is positive for a solution for this inequality? So 4 square is 16 minus 9 divided by 4 plus 5. That is 9 greater than 0. That's true, right? It means this solution, this interval is a solution. So our solution is second interval and the fourth interval. So let's write down second interval and fourth interval. So second interval is from negative 5 to negative 3. Negative 5 to negative 3. Negative 5 is not a solution. It means we have an open circle, parenthesis. Negative 3 is not a solution. We have an open circle, parenthesis. Fourth interval is from positive 3 to positive infinity. At 3, we have an open circle, so parenthesis. And with infinity, it's always parenthesis. And we have a union. And this is the solution, okay, for this rational inequality. So you have to check for each zeros, okay, and you have to check for each testing points. Okay, let me do example. So this is from your homework. Okay, let me do number 31, okay. Before that, do you have any question? Okay, so number 31, this is a homework, okay, this is your homework. Let me do for you. So we have x times x plus 1 divided by 1 plus x square greater than equals to 0. This is our what kind of inequality? Rational inequality. Okay, first step, we are making 0 on the right side. We already have 0 on the right side. So let's go to the second step. We factorize our numerator and denominator. Now, are we required to factorize, or we already have in a factor form? We already have in a factor form, right? So we can skip factorization. Or is there any way we could factorize denominator? We have 1 plus x squared. So we can't factorize 1 plus x squared, okay? So we can't factorize this. So we already have factor form. So let's find the zeros, okay? And the number that make denominator equals to 0. Now, let's take each factor. So we have x as a factor. For what x value this factor is 0? For what x value this factor is 0? 0, right? Okay, for what x value this factor is 0? For what x value this second factor is 0? Negative 1. Okay, next thing. Do we have a number that make denominator equals to 0? So we have a x square, right? Like whatever number you choose, you always get a positive number. Okay, we can't get a negative 1. So there is no number. So these two are the numbers that we use to divide the number line. So we draw a number line. You draw a number line. Negative infinity, positive infinity. Use these numbers to divide this number line. So let's say we have a 0 here, negative 1 here. Okay. Now we choose a testing number. So let me choose negative 1. So in between 0 and, oh, that's not right. That's not correct. So negative 1 should be on the left side, right? So in a number line, we should have in an increasing order. So I'm sorry. So this has to be negative 1 and this is 0. Always write a small number towards the left side and the bigger on the right side. Okay, let me choose negative 2 here. In between negative 1 and 0, let me go with negative 1/2. And so on the right side, let me choose 1. Now let's check whether all these, so you have to check for negative 2, you have to check for negative 1, negative 1/2, 0 and 1. So we check whether these are the solution for our inequality or not. Now let's check negative 2. So our inequality is x times x plus 1 divided by 1 plus x squared greater than equals to 0. Okay, now is our negative 2 a solution? So we have a negative 2 plus 1, that is negative 1 divided by 1 plus negative 2 square is 4, greater than equals to 0. So we have negative 2 times negative 1, positive 2 divided by 5. Is that greater than 0? Yes, right? So 2 divided by 5 is greater than 0. So this interval is our solution. Now what about negative 1? Let's check whether negative 1 is a solution or not. So you substitute negative 1 for every x. So negative 1. So you have negative 1 plus 1, that is 0, divided by 1 plus negative 1 square is positive 1, greater than or equals to 0. So we have 0 times negative 1, 0, 0 divided by 2 is 0, and 0 is equals to, so we have equals to here. So 0 is equals to 0. That's true, right? It means we have a closed circle here. So negative 1 is a solution. It means closed circle. Now what about negative 1/2? So negative 1/2 is negative 0.5, and negative 0.5 plus 1, that is positive 0.5 divided by 1 plus negative 0.5 square, that is 0.25 if I'm not wrong. But we get some positive number, so we just need whether it's a positive or negative. Okay, now in the numerator, negative 0.5 times positive 0.5, we get some negative number, right? Negative number divided by positive number is, we get negative number greater than 0. That's true or false? Negative number is greater than 0. That's false, right? So this interval is not a solution. Now let's check for the 0. So if we substitute 0 for every x, so we have 0 times 0 plus 1, 0 divided by 1 plus 0 square, 1 greater than equals to 0. So we have 0 is equals to 0. So that's true, right? So we have a closed circle here. So closed circle at 0. Now let's check for 1. So is our 1 solution for this inequality or not? So 1 times 1 plus 1, 2 divided by 1 plus 1, that's true, it's greater than 0. So this is the solution. So let's write down the first interval and third interval. These are solutions. So from negative infinity to negative 1, do we use parenthesis or bracket? Bracket, because it is a closed circle. Negative 1 is a solution, bracket. Okay, the last interval is from 0 to positive infinity. We have a closed circle here. So bracket and parenthesis with infinity, and we have a union. And this is the solution for this inequality. Okay, let me do one more. Do you have any question here with this example? Okay, let me do one more. 25. This is also homework. Okay, your homework. And we have x cubed less than 2x squared plus 3x. So we have this inequality. What kind of inequality is this? Is this a rational? No, right? So if you find the variable in the denominator, that is a rational. Okay, but we don't have the our variable x in the denominator. So this is our polynomial inequality. First step, making 0 on the right side. Now how do we make 0 on the right side? So we have to get rid of this positive 2x squared and positive 3x, right? So we subtract this number on both sides. So we subtract negative 2x squared, okay, negative 2x squared on both sides, and subtract 3x on both sides, 3x on both sides. Okay, we make 0 on the right side. So this cancel on the right side. On the left side we have x cubed negative 2x squared negative 3x less than 0 on the right side. So yes.
Could you subtract it from the other side, or will I have to change this side?
So you mean you want to make 0 on the left side?
Is that possible?
Yeah, you can do that. You can subtract x cubed on both sides and make your left side 0. It's not that you have to make 0 on the right side. You can choose any one side. If you make left side 0, then you have to factorize right side. If you make right side 0, you have to factorize the left side. Okay, now we have this left side non-zero. Now let's factorize this. So we see x as a common factor in each term, right? So let's factor out x. Factor out x. If we factor out x from x cube, we have x square. If we factor out x from negative 2x square, we have 2x. If we factor out x from negative 3x, we have negative 3 less than 0. Now this is the quadratic form. We can factorize this using a FOIL method. So x is the number that whose product is x square. Now can we find a two number whose product is negative 3 and sum is negative 2? Two number whose product is negative 3 and sum is negative 2. That is negative 3 and positive 1, right? Negative 3 times positive 1, negative 3. Negative 3 plus 1 is negative 2, less than 0. Now let's find the zeros for each factor. For what x value, this x is 0. For what x value, this factor is 0? 0. Now for what x value, this second factor is 0? 3. For what x value, this factor is 0? Negative 1. Okay. Now we use this number to divide our number line. So we have a number line negative infinity. So positive infinity on the right and negative infinity on the left. So we have a negative 1, 0 and 3. Okay. We choose the testing point. So on the left, let's choose negative 2. Okay. You can choose any number. Let me go with a negative 2. In between negative 1 and 0, let me go with negative 0.5. In between 0 and 3, let me go with 1. And on the right, let me choose 4. Excuse me. Now we check all these numbers, okay, including these zeros, are the solution or not. Now what about negative 2? So our inequality is, let me write down here, x times x excuse me, minus 3 times x plus 1 less than 0. So this is the inequality. So if you choose x equals to negative 2, so you have negative 2, negative 2, negative 3, that is negative 5, negative 2 plus 1, negative 1 less than 0. Is it true or false? We get a negative number, right, when we multiply this. So this is our solution. Now what about negative 1? Let's check negative 1. So if you substitute negative 1 for every x, negative 1, negative 1 minus 3, negative 4, negative 1 plus 1, 0 less than 0. True or false? It's a false. So negative 1 is not a solution. So we have an open circle. Okay. Now let's check with a negative 0.5. So we have negative 0.5, negative 0.5 minus 3, that is negative 3.5, negative 0.5 plus 1, that is minus 0.5 less than 0. So we get negative number less than 0. So this is solution. Second interval is also solution. Let's check for 0. So 0, 0 minus 3, minus 3, 0 plus 1, 1 less than 0. 0 is less than 0. This is not a solution. So we have an open circle at 0. Okay. Now let's check for 1. So 1, 1 minus 3, minus 2, 1 plus 1, 2 less than 0. That's true, right? So that's true. So this is the solution. Now let's check for 3. Is a 3 solution or not? So 3 minus 0, sorry, 3 minus 3, 0, 3 plus 1, 4 less than 0. That's false. So 3 is not a solution, open circle. Now finally 4. So 4 minus 3, 1, 4 plus 1, 5 less than 0. That is false. So this is not a solution. So our first interval, second interval and third interval are the solution. First interval is from negative infinity to negative 1. We have an open circle, so parenthesis with infinity, always parenthesis. Second interval from negative 1 to 0. And both have an open circle, so parenthesis. Third interval from 0 to 3. Both have an open circle, so parenthesis. Union. Do not forget this union, okay? And this is the solution for this inequality. Okay, let's do this much for today. Okay, if you have any question